Question number 41. Here they have given one screenshot. This contains 4 tables. Okay. Now they given some conditions to this 4 table and ask us to find out the storage mode for each table. Let's see, for customer table need to be refreshed daily. Date table once 3 years. Sales table near real time. Sales aggregate once per week. Okay. We can keep these points aside. Now go to Power BI and see the data. Now how can we change the storage mode of the table? Go to the model view, select the table, expand the properties pane, scroll down, go to advanced pane. Here you can see the storage mode. You can, if you import the data with the storage mode direct query, you can change it to import. If you get the data as an import, you cannot change to direct query. Okay, this is the condition. Now it's a direct query, so we have all the options, dual import and all. Now let's see for which table which storage mode is perfect. Now from this table model view, we try to find out which is the fact table, which is the dimension tables. Here you can see sales is the fact table which contains all the data, and we derived date table from the sales table, and customer key with customer table. So this date and customer tables are the dimension table, sales table is a fact table. Basically fact table contains lot of data, dimension table contains somewhat small data. Okay, coming to a sales aggregate, it's somewhat summarized value. You can see total sales values are there. Here you can assume sales aggregate will not contain any big size data, it will have some summarized small data. Okay, now come to the storage mode. Import, let's take import for this 4 table where import can perfectly suitable. Sales aggregate, why? Because it will have one group of values, total sales, and the size will also small, so import will easy to adopt here. So sales aggregate import is the correct answer. Next, coming to direct query, which table will useful here? Sales table is the large data. Fact table, it contains large data. So here direct query will helpful for us to take only the required data, and in condition also they mention near real time they need. So whenever the data changes, we can easily predict in the direct query. So sales table will have direct query. And coming to date table and customer table as a dimension, here dual mode takes place. Why? Because whenever we need, we can make this table as an import, and whenever it's need, it can be a direct query. It will automatically switch. That's why we are choosing the dual mode for this dimension. If it's need any data from the large one, it's use direct query. Any data from a small one, it will use import. So both storage mode will accept in the date table, both storage mode will accept in customer table. So basically dimension tables have dual, sales aggregate import, aggregated value import, and fact table sales direct query. Okay, now see the options: customer date dual, sales direct query, aggregate as a import. Question number 42. Here they have given 2 tables, Microsoft Excel tables. One is customer, another one is address. Let's see this sample table in the Power BI. Here you can see customer table with the given columns data, likewise address table with the given columns data. Now what's the question? We need to make this 2 table as a one. Okay, we need to create a new query that has only one row per customer. Okay, what's the requirement? We each row must contain city, state, region, country for each customer. Okay, they must need this 3 column values and all the customer values. Okay, one row per customer, each customer we need. What are all the options they have given? Merge, group, transpose and append. Let's try this here. This is the first table, customer, and next table, address. Now the first table we need all the data. Okay, here all the customer data we need. In addition to that, the matching address ID is the column table, column between these 2 tables. In respect to that, all the data from the left table, customer, and the matching data in the right table. This is our requirement. Coming to the joining operation, we have 2 types: merge queries and append queries. Here we are adding the column city, state, country. Okay, we are merging the columns into the first table. So merge will work here. If you want to add rows to the table, you can go for a append. Simply merge means joining the columns, append means joining the rows. Append will stack one below other, table 1 on top of table 2, like that we can do append. But in our condition we need to join the columns city, state, country. So go for merge queries. Okay, we need to merge customer table with address table. Select the customer table and select the address table. Now common column between these two tables is address ID. Now coming to the join operation, as I said, from first table we need all the data. So go for left outer join. Will give you all the data from left table. And the right table we need only the matching data. So we can keep left outer. Now we can see all customers we have here. Each row represent a customer data. Now in the address table, common column is address ID, remove that, and we want city, state, country. So remove all other columns. Now we can see this is the final output table which contains each row per customer. Okay, now coming to the operation, merge is the correct answer. Group will not help you to join the two tables. Likewise, transpose will transfer rows to columns, columns to rows. That will also not work. Append will help to join two tables one on another, like joining the rows. But in our condition, we need to join the columns. So merge only the correct option. So option A is correct. Question number 43. Here they have given one sample screenshot of the column distribution. Now they have asked two questions from this screenshot. Let's see this data in the Power Query editor. Here I have one table. Here column name is state. Now you can see here I have total 76 values. Okay, out of 76, what's the quality of this column? Let's select column quality and column distribution in the view tab. Okay, here you can see 95% is valid, 5% is empty. Out of this column is, let's consider this column as 100%. Out of 100, 5% is empty. 5% of values is empty. That means you can see below sum of values are contains null, and 95% remaining values are valid. That's what given here. Coming to this point, 39 distinct, 4 unique. Distinct and unique. Unique means here 4 data are appears only once in this column. Like for example, here you can see some values are repeated. Okay, these values are not unique. You can see Delhi 2 times, Puducherry, Ladakh. Okay, likewise these are appears 2 times or 3 times. Those values are not a unique value. Which values appears only once? Here you can see Goa, Sikkim, Mizoram, Nagaland. Okay, these 4 values are appears only once in this column. So these 4 values are unique values. Remaining values, Tamil Nadu will appear 2 times. So this is not a unique. Kerala appears 2 times. It's not unique. Likewise, those remaining values are not unique. Coming to the distinct 39, it means the different value. Distinct means 39 different values are there. Goa is one value, Sikkim is one value, Mizoram, Nagaland, Tamil Nadu, 5th value, Kerala, 6th value, Karnataka, 7th value. Like that 39 different values are there. That's what 39 distinct values are there. 4 unique value means the values appears only once. Goa, Sikkim, Mizoram, Nagaland. So those are 4 unique values. Coming to the question, here they have asked there are dash different values in state including nulls. Okay, as I said 39 distinct values. It means 39 different values are there. Like Goa is a one value, Sikkim 2, Mizoram 3, Nagaland 4, Tamil Nadu 5. Likewise, okay, 39th value is null. 38 Nagar, 37 Andaman, like that 39 distinct value including null. So Here the correct answer is 39. Next question, there are dash non-null values that occurs only once in this state. Okay, here totally 4 values. Goa only appears once in this column. So likewise 4 values, Sikkim, Mizoram, Nagas, and 4 values are unique values. Unique values means appears only once in the state column. So 4 is the correct answer for second question. Question number 44. Here they have given one same sample table with the columns. Okay, let's see this here. Here you can see sales ID, sales date, status, something. These columns are they have given. Now they are saying in the analysis they are using only the date part from the sales date field. It means in this column they are not using the time, they are only using the date from sales date column. Okay, they didn't touch cancelled date. Okay, they are using only the date from sales date field. Another condition, only rows with status of finished they are using for the analysis. Like here you can see first row, third row and fifth row having the status finished, so they are using these 3 rows for the analysis. The cancelled state 2 and 4th row they are not using. Okay, this is the point from the question. Now we want to reduce the load times of queries. What are all the option we can do? Here they said only the status finished they are using, so we can remove the cancelled row. Okay, now it's optimized. And coming to the date, they are using only the sales date. Okay, date from the sales date field. So cancelled date actually it's null, so they are not using. So select that column and remove it. Now it's look perfect and reduced. Now our load time will got reduced. Let's explore the option. A, removing rows, status value cancelled. Yes, they need only the status value finished. Second option, remove sales date. No, this will not correct because they need a date part of sales date field. So we cannot remove that column. Change the data type of delivery time. No, delivery time they didn't talk about. So changing the data type will not reduce the load time. Split sales date into separate date and time column. Here you can see in sales date, if we are splitting this into date and time, it's easy to analyze by date, but the load time will got increased because we are increasing the size by adding the time column. Okay, that don't need here. We need to reduce the load time, so D option will not be suitable. Last one, remove sales cancelled days. Yeah, it will work because we don't need cancelled date, we need only the sales date, so we can remove the cancelled date columns. So removing the rows and columns will help us to reduce the load time. So option A and E is the correct one. Question number 45. Here they have given one sales table that have a related date table. Okay, now they want to calculate sales previous year. What's the condition? Okay, that measure will calculate the total sales from equivalent month of previous year. Okay, let's see this in the Power Query Editor. I have a sample table sales 45 and date 45. Let's try to see its data in the table matrix. Table visual. Okay, this is the date and the sales value. Okay, for January 1 the total sales is 1000, February 1 1200. Okay, now total sales is okay given like this. Now let's see, we want to create one measure. Okay, they have given the formula for that, sales previous year. Okay, they have given the formula here. What's the condition? We want to calculate the total sales from the equivalent month of previous year. Okay, now we want to calculate, so we use calculate formula. Now first one they will give one expression, next one we need to give the filter. First is the total sales. Okay, we have a measured total sales which will give you the total sales for that month. Next one, we need to select a formula here, dates month to date, okay, parallel period, same period last year, total MTD, month to date. Here we don't need to calculate any month to date calculation, we are calculating the equivalent month of previous year. Okay, so first and last option got eliminated, parallel period and same period last year, two options we have. Here they said previous year equivalent month. Okay, for example, if you are calculating a sales for a month of February 2024, the result need to be a February 2023. So here you can see same period last year we need. Equivalent month means equivalent month of previous year, February 2024, equivalent month of previous year is February 2023. So same period last year we need. So we are giving same period last year in the formula. Okay, try to give same period last year. Here you can see the expression is date, only one argument with the date expression. Here you can see only one argument, date, date of date, not month or year. Okay, so date, we are giving the formula here. Now try to include this in our table. Now you can see, easily see, for January 1 2024 the sales previous year will give you the value of January 2023. Likewise, now try this with parallel period. Okay, here you can see for parallel period we need three arguments. Okay, first one is, for parallel period you need three arguments, date, number of interval, how much you want to go back, and the interval value. Okay, returns a parallel period of dates by given set of dates and specified interval. Okay, for example 1 year back or 3 year back, what's the value, like that it will give by intervals. Okay, but here we need the equivalent month of previous year, so same period last year will work. So here the correct answer is calculate same period last year and date. Okay.